All right, so last time for our exploration, we also did another type of polar graph called roses. They were of the form, I think we had it as r equals a, probably plus or minus a cosine of n theta, and the same thing with sine. So now it's just one term. We're not adding anything to them, just these guys. And we talked about number of petals, and hopefully you remember the pattern for that. So if n is an odd number, I would have that number of petals. So this graph is going to have 3 petals. Maybe you guys also caught on that the petal length is going to be 2. And I still like to do a little XY graph. So I'm also going to graph, a little big here. I'm going to graph this guy as y equals 2 cosine of 3x. And the reason I didn't give us a grid is because I don't even want us to be that accurate here. We'll find a couple points because now the period of this graph is 2 pi over 3. And I actually think maybe a little more helpful for these just to go with degrees. So 360 divided by 3, if you want. Some of them get a little tricky with radians. I'm going to actually leave it. So I'm going to put some points on here. Our amplitude's 2, so this would be 0, 2. I like to just label the maxes and mins. So this guy would be pi over 3, negative 2, and 2 pi over 3, 2. So some good points for our graph, and I'll start graphing them. So 0 degrees. I'm going to put 2 out here, rescale it, right, because we don't need it to be so tiny. And I'm actually going to label this point. Now remember, in the polar grid, we do r theta. So this would actually be the point 2, 0. All right, we also have pi over 3, negative 2. So this is where we're getting interesting, right? Here's the pi over 3 line, but the radius is negative. So we're going over here, 1, negative 2. Again, I think labeling is helpful to see this pattern here. So negative 2 pi over 3. So if we were graphing this, we would have gone towards the pole. I did have an x-intercept, so we have a point at the pole. Going to this point, let's see what's next. 2 pi over 3, 2. So my point's up here. So it's actually coming back. My radius getting smaller, getting close to the x-axis, and then going back into this guy. If you kept going with this graph, my next key point would be, let's see, pi over 3, 2 pi over 3, 3 pi over 3, or pi, negative 2. So pi, negative 2, which is a point that we already have. So we are all set with that rose. I'm going to do one more. I really like this graphing style, but whatever method you guys have, feel free to use it that way. Give me 2 seconds because my computer is dying. Let me see if I can pause this recording for us. All right, we're back. All right, so we'll graph this guy next, 3 sine 2 theta. Again, I always like to think about symmetry. Sometimes I know I forget to mention it here, but this sine graph for our roses has theta equals pi over 2 symmetry. So that's almost like y-axis symmetry. And I'm going to draw a little sketch of what this sine graph would be. So the new period would be 2 pi over 2, which is pi. So I'm going to mark these max, or yeah, just the max and min values. So this guy, if this is pi over here, would be pi over 4. And this guy would be 3 pi over 4. So let's get these on this graph here. So pi over 4, we'll have the point 3. So I'm going to keep the scale the same. And then we had, so to start, I should even put 0, 0. We have a point at the pole. And then think about the graph, right? The graph gets farther away. So the radius is getting bigger as your points as you go through our angles. Then our graph comes back down. So the radius gets smaller, and then you hit 0, 0 again. Well, crazy graph there, crazy screen. We hit 0, 0 again. So we're going back to the pole. And that's one petal of the rose would be like one little loop mountain of our sine graph over here. Then 3 pi over 4. So now these are all negative values. So where we would be in quadrant 2 between pi over 2 and 3 pi over 4. So over here, we're jumping across the coordinate plane for the negative values. Till I get to that midpoint, 3 pi over 4, negative 3. So it's going this way, and then we're going back to our pole. Now, two ways I can finish this graph. We know it has symmetry, so I can just reflect these petals right over. Or you could just actually keep your sine graph going over here and think about like where the max and mins are, those are going to be the other petals. So this is 5 pi over 4, 3, which is that point up, or this point right here. And then 7 pi over 4, negative 3, which is that guy. Remember, if you just label the points on your grid, to label them appropriately. So this guy is 3 pi over 4. This guy came from negative 3, 3 pi over 4, right? There is no point on this graph. Like 3, 7 pi over 4 would not be a point, right? That doesn't work in the equation because 7 pi over 4 is over here negative 3. So just be careful when you label. Sometimes you might be okay getting away with it, but not all of the same coordinates actually work in the equation. This was that 3, 5 pi over 4. All right, so you guys finish those off. Our last graph is a little bit different. Maybe I'll do one more video to graph that one with you and to wrap up the worksheet.